So, hi, Chips. How you doing, brother?
Yeah, hi. Sorry, I just saw the space, and it's something I've been following a bit. So when I saw solved beside quantum gravity, I just had to jump in. Sorry to interject. So I
No,
think
don't be sorry. We can just have a
oh,
conversation,
okay,
bro.
okay, all right. Okay, all right. So the reason why I have been a bit obsessed with quantum gravity, uh, at least based on my research. So this is a hobby. I mean, like a bit of a hobbyist research on it was because of what it portended. So if it was solved. So when I did a bit of research, because I'm obsessed with space,
Mm-hmm.
and I'm doing a bit of personal research on what I call artificial gravity generators. So basically, what that means is that how can space stations, or space vehicles have gravity that would allow people, not to be weightless? So how can you mimic what happens on Earth, which is we are pulled into gravity.
Mm-hmm.
We are pulled to the Earth's mass via gravity. That is the mass of the Earth itself. So how can that happen in space? And then I went down the rabbit hole, and then so I went into what was the current research on gravity, and then so I think I don't know, correct me if I'm wrong, but there was the proposal that if quantum mechanics and the gravity research merged together, then they would find the particle. They would find the particle that is supposed to be responsible for gravity, and so they called it graviton. Just the same way you
Yes.
have, electrons and all that. So they were saying that, okay, we don't know what particle is particularly responsible for gravity, but if there was a merging, and if we did the research and we would ideally find something called graviton, which would explain, at a fundamental level why gravity happens at a more macro level. And then, so if that was then discovered, ideally we would then be able to manipulate graviton the same way we can manipulate the atoms,
Yes.
and then we can then beat whatever laws gravity currently limits us. So in terms of, you know, going the whole warp drive and whatever, things then become more possible, and then mass does not become an issue again with things like speed of light. So I've been following that. So um, when I just saw solve behind it, I just had to just come and find out
Yes.
what exactly the state of the art is.
Yes. You are in the right place. So let me. Are you from Nigeria?
Yes, yes, I am.
Yes.
I'm from
Okay.
Nigeria.
So I'm from Cameroon. I was born in Cameroon.
Okay.
And I came to America when I was 12 years old. But since I was in Cameroon, I was obsessed with this question, and the question was, what are the fundamental rules of the universe? So, like, for example, if we strip everything away, everything that we can see, everything that we can measure, and we just go to the baseline substrate, right? What is that thing? And if we discover what that thing is, let's say it's some rules, right? Then would these be the rules that govern everything if we get to the fundamental substrate? And that's kind of been the angle that quantum mechanics took, right? Quantum mechanics is like, okay, let's try to figure out, let's just keep going deeper and deeper and deeper, and we ended up discovering the different particles. We have quantum chromodynamics, we have quantum mechanics. We have this language that gives us a way to model subatomic systems, right? And you mentioned the graviton. Uh, the graviton is a hypothetical particle, right? It hasn't been discovered yet.
Yeah.
But the graviton, uh, the physicists assume that because they discovered particles, other particles at the subatomic scale, that this hypothetical particle, the graviton, might exist, and they can attribute this graviton to the force of gravity, right? And this will allow them to unify gravity, um,
Forces.
electromagnetism, the strong force and the weak
Mhm.
force,
The
right? So
weak
the goal
force.
the
Yeah.
goal essentially is these four forces, right?
Yeah.
And quantum chromodynamics unified three of those forces: electromagnetism, strong and weak force. And then the one thing that has been left has been that was left was gravity. And gravity has been very difficult to reconcile with these other three forces. And
Yeah.
gravity essentially uh, allows us or gives us an understanding of macroscopic things, the big things, the celestial
Yeah.
systems, right?
Yeah.
And quantum mechanics, which is the unification of the three other subatomic forces, gives us an understanding of microscopic things, small things. So the question
Mm,
basically is this: is there a way to unify these two perspectives or these two different languages? So that's the goal
mm.
of quantum gravity, is to unify these two. And
So that everything makes sense.
yes, so basically, I've been obsessed with this question too. By the way, you said you were obsessed with it, but I've been obsessed with it pretty
Mm,
much my whole life. Like, I've been literally sleeping. Like, actually, if you go on the comment section, I posted
mhm.
my most recent paper that I just published that tried
Oh,
that I believe I might have solved this problem. Um,
wow.
so essentially, what I realized was, 420 earlier mentioned the word relationships, right? Essentially, we're looking for a language, or a general language, to model all relationships in the universe,
Yeah.
all
Based on the
relationships,
theory of everything.
right? Because
Mhm,
systems emerge, right? They interact with each other, and then they die, sort of like humans. We emerge, we're birthed, we interact with our environment, with our families, with nature, with the universe, and then we die. Uh, and this seems to be an aspect of all systems in the universe. Think about the supernovas, right? Galaxies
stars.
die,
Hmm.
things are birthed,
Yeah.
stars are birthed, stars die.
Are birthed.
So there's emergence, there's interaction, and then there's death, right? So essentially, it's
Yeah.
all about relationships, whether it's the subatomic relationships or it's celestial relationships, right?
Mhm.
Planets, there's a revolution. There's everything is interacting with each other, right? So the
Mhm.
question is, what is the governing principle of all those interactions,
Behind all of them.
right? And essentially, my assumption is that it's a language, or it's a fundamental language of reality, or an algorithm, or a fundamental algorithm that governs everything, right? So it's like a
Mm.
rule.
So are you trying to collapse the four forces into a singular um, model or a singular I don't know definition? So basically, by saying it's a single, it's it's a principle. You're basically saying that those four forces can still be brought down into a singular language that then branches out into four of them.
Good question. Um so these four forces, right? So when you look at the force of gravity and all the other three forces,
Mm.
the assumption is that they might just be a different interpretation of a more
Mm.
fundamental thing.
Yeah,
Does that make sense? So
yeah, it does.
instead of us, and currently academia is trying to reconcile them by trying to like stick them together, trying to like marry them together, or glue them together. uh that's why they have the graviton and all that stuff. But
Mhm.
my assumption is that these these are just different interpretation of the same fundamental rule. Like, there is a
Mm.
baseline substrate that governs the whole thing, right?
Yeah.
And if we discover that thing, then that will be the thing that birthed all these different rules. Does that make
Well,
sense? Let's do this.
I,
Let's
I
do this. Let's do this. So, Chip, do you have a computer in front of you?
Yes, I do. Yeah.
So, do you guys both have Chat GPT?
Hmm.
So,
I do.
to go and take my paper, the paper that I pinned it in the comment section. I don't know if you've seen it.
Yeah.
Go and download that paper and put it into ChatGPT and ask it, does this paper unify quantum quantum mechanics and gravity? Because
Okay.
the paper is 120 pages long. So I know you guys are probably not going to be able to read it while we talk. But if we do that, we can work throughout the paper together, and you can see my logic.
Okay. But well, while I do that, do you want to just give a snapshot for why you think it's unifies it? Because I'm trying to sign into my Kindle. That might take
Okay,
a
no,
bit of
take
yeah.
your time. So essentially, my understanding, and bear in mind, okay. So do you know who Michio Kaku is?
Yes, I do.
Okay, so
A Japanese.
when I was still in Cameroon, right? I watched the documentary that Michio Kaku released. I forgot what it was. I think it was the God Equation. I think I was like 11 years old, and the God Equation, the documentary. Michio Kaku said something very profound, and that triggered something in me that made me want to go on this journey to solve this problem. He said the God equation, or the equation that we're looking for, that Einstein, Schrodinger, Paul Dirac, all the great academics you can think of, physicists you can think of that were working on this problem, that they were looking for a simple 1 inch formula that can model all the whole of the universe, that can model all systems in nature, right? So the key point here was that what we're looking for is something very simple, and it's something general that can give us the rules of how everything in the universe works. Does that make sense?
Yeah.
Beautiful, beautiful. So essentially, the key point here is that a lot of people that are working on this problem, they think that the universe is complicated, right? But
Yeah.
the truth is, the universe is actually very simple. It's the language that we use to understand the universe that might be complicated. So the basic rules of the universe might actually be so simple that the formula is literally 1 inch long. And that's the formula in
Mm.
my paper. So my paper focuses on transformation. I believe transformation is like the rules of transformation is fundamental to nature because everything transforms. Remember, I said initially, Chibs and 420. I said everything is birthed, so everything emerges, then everything interacts with its environment, then then it dies, right? So there's birth, there's interaction, and then there's death. So that's
That's also sort of a bell curve on a.
correct. Correct. Go ahead.
I'm trying to just imagine it linearly. No, yeah, no, I'm just trying to visualize what you're saying because I won't say it's a cycle, but it looks more like a bell curve where you start with a zero, then you peak, and then you go down back to a zero.
Yes.
Don't mind me. I'm thinking while you're talking.
No, no. Feel free to interrupt me. I like
Yeah,
to just have a regular conversation. I don't want to sound like I'm giving a lecture or something.
yeah.
Um, but you know what we can do? So if you read the abstract of my paper, you will understand a little bit of what I'm trying to do. Have you read the abstract?
I don't. So I'm stuck at Amazon sending
No,
me
no, 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 no. Don't go on
in the code.
Amazon.
So I
Don't
think
go
I'll
on
do.
Amazon. So I posted the paper on Google Scholar. I can send it to you. I can send it to you.
Oh, okay, okay. Oh, sorry. I missed that. I went to the Amazon link.
Yeah.
Okay,
You don't
all
have
right.
to
I'll
buy
go
it,
to
bro.
the.
I'll send it to you for free. I just put the
I'll,
Amazon to sell it just for people that want to support me. But
yeah.
it's available for free for everybody.
Oh, great. Okay. Yeah, I'm reading the abstract. So I guess the triangle is a delta. Then after that
Delta.
is an infinity.
Mm-hmm.
I'm not familiar with the third symbol.
The circle. It's just a
Yeah,
circle.
just a
Omicron.
circle. Okay.
Yes. So
So
so basically, we're looking for formalism that can encompass how everything in the universe interacts, how it basically emerges, how it interacts with other things, and how it dies, right? So the formalism is triangle, infinity, circle. Imagine a triangle being emergence, birth. The infinity means interaction. Remember, there's infinite interactions happening in the universe, infinite levels of interactions. Everything is interacting with everything, right?
yeah,
At the atomic level, at the microscopic scale, even at the human level, there's interactions, right? And then there's
yeah.
death. That's fundamental to everything, and that's what the circle represents. So if you read the abstract, it should give you a brief summary of what the paper focuses on. Because remember this, guys, like physics is just a language, right? It's a language that we invented to give us an understanding of nature. And the truth is that it's just one of the languages that we could have possibly discovered. There might be other languages that we haven't discovered yet, right? So I think there's a more fundamental language that we could use to model the universe that is more complete than physics, because physics has reached like a roadblock, and the roadblock is it gave us two different understandings that cannot marry each other, cannot unify. So what if the unification is beyond physics?
The moment I just put in your abstract, it began to just um answer those questions without me. So basically, There are a couple of things that it's saying that is just so it says it answers the question of the measurement problem. And the measurement problem basically says that electrons, because everything is about how electrons are, you can never see where they are
Mm-hmm.
until you measure.
Uncertainty. Yeah.
That's what it calls superpositioning basically.
Yes.
So basically says that this explains that, because I know that there was that conflict. This stumped Einstein when he was like, God does not play dice with the universe, and people were basically saying, the whole Schrodinger thing. So you are saying that this explains that, and then he also says it explains the black hole information paradox, where basically theoretically normally information is supposed to get destroyed in a black hole,
Yes.
but this is supposed to explain that, and also the singularity um issue
Yes.
also. So I think the first question I was going to have was that what is the interaction between, so I was trying to read up on what Omicron was, because I'm familiar with Infinity and Delta.
Yes.
But my question was, normally whenever I see equations, I'm used to seeing something that joins them together. Like you have board mass, so you have, is either it's a plus or it's a triangle. Or so I'm trying to ask, what is supposed to be the interaction or the relationship between those three symbols.
Yes. So did you
So
did you put the whole paper? Because I think you can download the paper, get the whole PDF,
okay,
and,
I wasn't able to download the whole paper
and
yet,
put the whole
so
PDF
maybe
into ChatGPT. Like literally, the
okay,
reason why the paper is so long is because I spent a long time working on it, and I basically answered every
answered
possible
those questions.
paradox, and I resolved all the possible anomalies that conventional physics, classical physics had when it came to this to understanding the universe. For example, the black hole information paradox, right? The idea that in a black hole there's infinite density, so essentially all information gets lost forever, right? And with my system, that's not the case. Have you heard of the Hawking radiation?
I've heard of it, but I didn't read too much about it.
Correct, correct.
So yeah,
So Hawking basically proved with
you're
his
talking about black body radiation.
So Hawking basically proved with his work that black holes emit particles very slowly over time,
Okay.
right? So essentially, the information is never lost, and the black hole actually releases the information after. This is very important for 20, and Chips will also appreciate this. So my work, right, Chips and 420, I have a formula, not an equation. And this is very important, and I'll tell you why. An equation requires an equal sign. Equation. And the equal sign was invented by this guy called Robert Record in the 1400 15th century, early 15th century. So the equal sign essentially it's an axiom, right? It says that the thing on the left is equal to the thing on the right. And the reason why our mathematics today had issues with reconciling the rules of the universe, we'll get into this fundamental principle, is that our mathematics is limited by the concept of equality. So basically, if you look at math, right? If you mention addition, subtraction, multiplication, division, all those calculations only work when equality is the accepted axiom. Does that make sense? So basically,
Yeah.
our mathematics requires equality to work. But the issue with equality is that we cannot model how the universe works fundamentally with equality as our base axiom, because equality doesn't exist at the fundamental level. It's an abstraction, right? So the reason why we have infinity here is because the infinity models all the different possible interactions in the universe. Because remember, there are infinite numbers of levels of interactions, right? Think about the human. The human body has trillions of atoms, right? And they think about the universe. The universe is so big and complex. So equality is.
This actually,
Go ahead.
yeah. Okay, not to, please. I would like you to continue this because my mind is actually running in many directions. But what this triggered to me was when I looked at how um Newton was so right and mind blowing when he came up with the laws of motion. and then how that was disproved by Einstein, simply because Einstein magnified the lens by like 1,000 scale. So
Yes.
right,
Hmm.
Newton was focused on what was happening on Earth, and it just a bit above that. Then Einstein moved down to like the galaxy.
Yeah.
And then when because I was thinking about the fact that there are there are a billion um, pl- planets in our solar system and a billion solar systems in our galaxy,
Hmm.
and there are probably hundreds of trillions. So that means that if somebody was to zoom 1,000 times away from Einstein's from what Einstein was looking at, there'll probably be another law that would be, so it's almost as if the laws we are discovering are like they're like sets within subsets within subsets within subsets. So there's something larger, and it's just as far as we can see that we're now
Chibs,
using.
you are very wise, bro. You are very wise. That's exactly what's happening, and that's exactly
So
what we
like
have to
the
do.
farther we zoom out.
Yes,
Mm,
that's exactly what we have to do, and that's why my formula is a more general version of Einstein's E equal mc squared. Does that make sense? Because you
yeah,
know how you mentioned zoom out, right? We're essentially
yeah,
zooming out. So remember, Newton, the apple fell on his head. He gave us a model, F equal to ma, force and acceleration, right? He gave us a model of
yeah,
how physical things work, things that we can interact with and touch, apples, even right? And then
yeah.
Einstein came, and Einstein zoomed out. Einstein said, "Okay, wait a minute. We can go more general. We can zoom out more." And then Einstein gave us a model of the universe, but he hit a wall, and the wall was the black holes. So whenever you interact with really dense parts of the universe, his work relativity doesn't work anymore, right? Because the black
Mm,
hole is so dense that light can't even escape. So his equations fail when you get to really dense parts of the universe, which means that we have to zoom out further to get a bigger picture of his equation. The same way his equation generalized Newton's F equal ma. So it's basically
mm,
F equal to ma, then it's E equal mc squared. Then there has to be one that is more general than E equal mc squared,
mm. Yeah,
right?
that's
And
actually
here is my contribution. My contribution was noticing something very, very, very that nobody ever noticed before. Is that we don't need to use the equal sign to model how systems work, because equality itself as a concept limits our understanding of the universe, right? Because we're trying to equate things that are not equal.
mm,
There's transformation in the universe. Things are transforming into each other. Equality is not a fundamental rule. It's just one of the rules. Does that make sense?
yeah,
And
yeah,
and that's why you have my infinity in the middle. So essentially, check out how genius is shapes, right? E,
mm,
energy becomes the triangle, right? Delta, right?
yeah,
Then the
yeah.
equal sign becomes infinity. So we are going to generalize equality to infinity, because think about it like this: infinity is a more general form of equality, because infinity models all interactions, not just the equal
Mm.
ones. Does that make sense?
Is that because interactions are continuous?
It's
And
inclusive, it's not as
Yes,
exclusive.
exactly, exactly. And then mc squared, mass times speed of light squared. So remember, speed of light is just a constant in the universe.
mm,
It's like a measure, it's like a ruler, right? In our universe,
mm,
speed of light is like a ruler. So imagine a ruler that is
yeah,
12 inches long. That's
mm,
that's all the speed of light is, right? And then the mass is the only variable that is kind of arbitrary in the universe, because we have different things that have different masses. So essentially,
yeah.
mass times speed of light should give you the structure of the physical world, mc squared, and that's we put all that into the circle. So all that becomes the circle. We abstract that because all physical
That's the
things,
Omicron.
exactly, that's the omicron. So
Yeah.
essentially, my formula, which is not an equation because it doesn't have the equal sign, my formula is a form. It's a form that represents how things interact, or it represents relationships between things in the universe, right? Everything follows this simple rule: delta infinity omicron. That it's that simple. You said the three ingredients, right? Okay, let's call it ingredients. The three ingredients are delta, infinity, omicron. It's not that we're combining formulas or equations to create this formula. It's that this formula underpins all equations. So it doesn't say that these equations are invalid. Like E equal MC square is valid. F equal to MA is valid, right? But it's just not general enough to encompass all possible interactions. So yeah, so people get triggered by this, especially when I dismiss equality as a fundamental thing, right? The equal, and I'm not saying that equality is wrong. The goal here is to generalize beyond Einstein's understanding of mass, energy, and light, right? And for us to do that, we have to divorce ourselves from a limiting concept, from a limiting tool, from a limiting language. So equality is useful in Einstein's universe, right? But equality is not necessary when it comes to my universe or the universe where we have this formula, right? And but remember, I'm not saying that they're wrong. I'm saying that they're not general enough to give us the whole picture. So essentially, this formula is like a lens with really really high resolution, with the highest resolution, so we can zoom into the universe and see the most fundamental substrate, right? But if you look at the Einsteinian lens, it's a little bit blurry, so it gets us to the point where we understand mass and energy and light, right? If you use the Newtonian lens, you can understand force and mass and acceleration, right? But my lens goes beyond all those formalisms. My lens allows us to understand something that is beyond the material, beyond mass. Because remember, those are just abstractions. Mass is an abstraction. Light is an abstraction. Force is an abstraction. These are all abstractions, and these abstractions are not the most fundamental abstractions. So they work and they're consistent within the framework of Einstein, within the framework of energy. But when we talk about the fundamental rules, it's beyond energy. It's beyond mass. It's beyond speed of light. It has to be more general. Does that make sense, Chips?
Yeah. So, can you just take me through each of those symbols again? The delta now, that's a triangle. You said it stands for what?
So the triangle stands for delta.
No,
So
no,
let
yes,
me
yes, I know, I know. So the delta is, but what does it represent
so it
in
represents,
that
okay,
relationship?
correct. So you know what?
I know you mentioned emergence because I'm
Yes.
looking at some of the notes I took. You mentioned emergence, interactions, death.
So look. So go to page three. Are you go to page three on the paper? I want to show you something.
Okay.
So there is this principle that I came up with called the General Relativistic Principle (GRP), and I outlined it on this page on page three.
Okay. That's is it the core axiom part?
Yes. So do you
Symbols
see the
meaning.
you see the figure one? You see figure one?
So it says quantum domain. Is that the part?
Yes.
Okay.
Yes. So we can put the entirety of quantum mechanics into delta, right? And then we
Okay.
can put the entirety of relativity theory, general relativity theory, into omicron or the circle, right?
Okay. Yeah.
So, but if you look at page three, you'll see the relationship there. So
So it
essentially,
says
we start.
mediate. Okay.
Go ahead.
Mediator parameter. That's what the infinity is.
Correct. So the infinity is just a representation of all the possible interactions that we can have that happens in between triangle and circle. Remember,
Okay.
right? A circle is just a triangle with infinite sides. Does that make sense?
A triangle is
So a circle is just an infinitely sided triangle.
okay. Yeah. Yeah. I think I've seen
You
that.
see what I'm saying? So let's say you start with a s equal to 3 equilateral triangle, right? And then just keep adding one side. You see what happens when you keep adding one side?
If you zoom out, it's like a circle.
You get the platonic solids. You get the rectangle. Then you got the pentagon, hexagon, and
Hexagon.
you
Okay.
go
Yeah.
all
Yeah.
the way to.
Yeah.
So let's say you make let's say the triangle has a billion sides, for example,
Okay.
right? That's still a circle. That's still a circle,
Yeah.
right?
If you zoom out, it's a circle. Yeah.
But it looks really smooth when you zoom out,
Yes.
right? It looks like a
Yeah.
circle. But if you zoom in really closer, you'll see the edges still,
Yes.
right? So in theory, we can have a triangle with a trillion sides. In theory, does that make sense?
Yeah.
So this is the engine right here. So the engine is the transformation of a triangle into a circle can be used to model all possible interactions, all possible transformations in the universe. Because that triangle can be S equal to what's Avogadro's number? The number of atoms in the universe is a huge number, right?
Yeah, I don't know.
So we can say S equal to Avogadro's number, which is a really big number. And that's still going to be a triangle, but it's going to look like a circle if you zoom out. So
Mm,
basically, the formalism here is that delta infinity is all the possible in between polygons, s equal
mm,
to any arbitrary number, right? That's whatever
mm,
this big, the smallest to the biggest size. So you can use this to model interactions at a macroscopic level, which is cosmological stuff like planets, galaxies, all that stuff. But you can also use the same language to model subatomic interactions, quantum
mm.
interactions.